Hi, we are continuing designing of 2-bit binary counter with enable input. Okay, I will wipe out unnecessary parts of the design process. Now we are ready to obtain J1, K1, S0 and R0 functions, logic functions. And we can do it by guessing the values of J, K, etc. or by using K-maps to minimize them. Try to guess J1 first. Looking at this is only define a single one here. And for these don't-care states we can put any values. So 2 zeros, 1 1 0 1. Perhaps it is sum, could be sum of Q1 plus Q0. No, this I can't find the solution. Perhaps enable times Q0. Enable times Q0 can be. It is enable times Q0 of t. I can't find a more compact version of it. What about K1? K1 can be, of course, the product of all of them, but also I can find that K can be enable times Q0 as well. Enable times Q0. Enable times Q0. Yes, enable times Q0. It is simply the same as J1. What about S0? Can I find the solution? S0, which is equal to, we can minimize these two ones to get to glue them together, having enable times not Q0, enable times not Q0 of t. Please do it at home using K-maps, because I am not sure if they are minimized. It is an inversion of, as you can see, that it is an inversion of S0. Okay, this part and this part. That's it. Okay, so hoping that these are minimum versions, we are now ready to draw the diagram. Because Q's are our Y's. So Y1 is Q1, Y0 is Q0. Okay, so I will now wipe out the table to draw the overall diagram of this counter. As before, we start doing this by putting two symbols of the flip-flops, first and the second. The higher bit, 1, Y1, is JK, and it is our Y1. And the lower is SR, Q, not Q, and it is our Y0, the state of the lower bit of the counter value. And as usual, always we connect together CK inputs, and we will follow these equations. J1, it is this signal J1, and must be realized by ending using AND gate. Q0 is this. I will connect this in this manner with external enable signal. It is enable. In these equations, I use E instead of EN, but you know that it's enable. J1. K1 is simply the same as J1. What about S? S0 is, sorry, it is a product, so again, AND gate, it's a product of enable with not Q0. Q0 is this, so not Q0 is here, this is not Q0, this is Q0, Q1, and this is not Q1. And you must connect this to S, S0, and this is S0. R0 is obtained by inverting S0 using NOT gate. And that's it. You can also have, a reset or clear input to set this counter initially to 0, state. Clear. And after this you clock and you can stop counting by putting enable to the ground, or enabling, you can enable counting when you return to 1. Thank you very much.